Alright, welcome back to our video on my channel, math_exe. This is another problem solving video, and these problems will be strongly related to exponents and quadratic equations. So let's jump into it. This is part A. So we need to solve for x if 4 to the x squared minus 3x plus 5 over 2 is equal to 2. And when you're dealing with exponential equations, you must rewrite this right hand side as 4 to the something power, and we need to figure out what this something is. So we need to find a number which we take 4 to that number is equal to 2. Well, we know the square root of 4 is equal to 2, and we can just rewrite square root of 4 as 4 to the power of 1/2. So this something turns out to be 1/2. And once you have written the right hand side in terms of 4 to the something power, you can just set the exponents to be equal. So if x squared minus 3x plus 5/2 is equal to 1/2. Subtract 1/2 on both sides, you get x squared minus 3x plus 4 over 2, which is just 2, is equal to 0. Now right here you can just solve this quadratic by either factoring, copying the square, or using the quadratic formula. And I'm just going to factor this. Notice that this will factor nicely into x minus 1 times x minus 2 is equal to 0. So our solutions will be x equals 1 and x equals 2. So this is part A. And for part B, we need to solve for x if 9 to the x squared minus 2x plus 1 is equal to 1. And like the trick before, we need to rewrite 1 as 9 to the something power. Now this something is actually simply just 0. And you may be wondering why, because, well, recall that anything to the 0th power, as long as that anything is not equal to 0, will be equal to 1. So I'm just using the fact that a to the 0 is equal to 1 for some for some real number a that is not equal to 0. So that means the exponent will be equal to 0, and therefore we can just set the exponents equal to each other. So we have x squared minus 2x plus 1 is equal to 0. We can factor this quadratic as x minus 1 squared, and therefore we only have one solution, which is x is equal to 1. Now for part C, it's a bit tricky because we have a function as the base and a function as the exponent, and that along will be equal to 1. Now the trick here is try to take all the exponent identities, and we need to find which one which will give us a output of 1. So we need to find when is a to the b power is equal to 1. So we need to figure out what a and b could be, and let's just substitute that into that. So after think about that, you'll be left with 3 cases, and we're just going to solve this individually. So for case 1 is where we have a is equal to 1, so that will be 1 to the b is equal to 1. So 1 to any power is equal to 1. Case 2 will be when b equals to 0, and we must ensure that the base is not equal to 0, otherwise 0 to the 0 power is undefined. So we have a to the 0 power is equal to 1, just like I said in the previous question. Now case 3 is a bit uncommon, but it actually gives us a special solution that is often missed in calculators such as Wolfram Alpha. So that is the case where the base is -1 and the exponent is even. Now just perhaps write b as 2k, where this k is an integer. So that will be negative 1 to the 2k is equal to 1. Alright, so let's just solve case 1 first. For case 1, we can just set the base equal to 0. Not equal to 0, but equal to 1. So we will have x squared minus 3x plus 1 is equal to 1. Subtracting 1 on both sides, you'll get x squared minus 3x is equal to 0. And you can just factor this as x times x minus 3. And that will gives us two solutions, x equals 0 and x equals 3. So let's just write those solutions down. For the second case, we need to set the base equal to 0, and that's pretty simple. We'll just have x minus 5 is equal to 0. That means we're left with x equals 5. Now we need to check that the base itself is not equal to 0, otherwise it will be undefined. So we can just substitute x equals 5 into the base. So we have 5 squared minus 3 times 5 plus 1. And you can just check this is clearly not equal to 0, so we're good. So let's just write that in the solution. For case 3 is where the base is equal to negative 1 and the exponent is even. So we can just set x squared minus 3x plus 1, which is the base in this expression, equal to negative 1. Add 1 on both sides. And then we can just solve this by factoring. Or you can just complete the square or use the quadratic formula if you would prefer that. That will give us x equals 1 and x equals 2. Now don't get too happy yet, because we need to check that the exponent will be even. So let's just check that and plug into x minus 5. When x equals x equals 1, the base will be 1 minus 5, which is equal to negative 4, which is even. So we're good with this. However, when x equals 2, we're left with negative 3, which is not even, obviously. So I just forgot to write x equals 5 on the last board. So the only valid solution for this case will be x equals 1. So we have 4 solutions. So we have x equals 0, 1, 3, or 5. And that concludes this video. So hopefully you guys enjoyed this. So please subscribe and goodbye.